Okay, good morning. Today we want to talk about trigonometry in the unit circle. In your group, I don't think there is something actually new, but I told you that I will assume that you have forgotten a lot of things, so I start from scratch, okay? But of course I will go faster because otherwise we will not be able to cover anything. And by the way, I taught this trigonometry in the right angle triangle for the not true technique, and I decided to upload that version to the YouTube. And I also put the link in the Google Classroom. So please always follow what is written on Google Classroom. Okay, so there was one section in Math 3C which was actually omitted by the schoolwork. I think let us read it here because I think it's from logical point of view it is essential, and that was the notion of the equation of a circle in general. So momentarily forget about the trigonometry or whatever. Let us try to do some geometry, analytic geometry for circles. I mean that if I have a circle, I want to find an equation for that circle. Okay? So when I say I have a circle, so it means that I have a center, yes? So let me call C for center. Okay, and then I have a radius. Of course, I have infinitely many radii, but here R, by R, I denote the length. Okay, I'm not denoting this segment because I have infinitely many of them. So I'm assuming that R is the length of one radius or every radii. Okay, so this is what you know. And then when I say circle, I exactly mean this rim. Here is called inside the circle, here is called outside the circle. So it's a difference between disk and a circle. When I say disk, in principle, I contain the rim and whatever is inside. When I say circle, I only mean this curve, this rim, yes? That's the circle. When we say circle, just imagine that I'll have a curve, nothing inside. Okay, so I want to try to understand this problem from analytic geometry point of view. So it means that the first question that comes to mind, what is an equation of a circle? So in analytic geometry, for example, you have points in geometry, but in analytic geometry, points are ordered pairs of numbers. So you can say a point with coordinates 1 and 5. 1 and 5 are numbers. They are supposed to represent a point with coordinates 1 and 5 in the coordinate system. And then if you go after a point, you have lines. And then you learn even from going to school that an equation of a line in general can be written in this form. Yes? So we learned that if I have a line, its equation is of this form for some particular values of a, b, and c, depending on the relative position of that line in the plane, and vice versa. Every equation of this form represents a line. Yes? Let us try to analyze this sentence a little bit more. For example, when I say that y equals to x, you already know a diagram or a graph for this one, which is the bisector of the first and the third quadrants. But can you analyze this? What is the meaning, by the way? I want you to refresh your memory a little bit. So when I say that this equation, by the way, this is not geometry, this is an equation, so it is in the realm of algebra. And this is a line, it's in the realm of geometry because that's a shape. But what I'm saying that this algebraic equation represents this geometric object. So you need to have an understanding, what is that? What is the meaning? What do I mean by this sentence when I say that this algebraic equation is an equation for this straight line? What do I mean? Because that is extremely important. When you draw the graph of y equals to x squared, it becomes this. It is parabola or something similar to this. What is the meaning? I say that this is the graph of this equation. So this means this is a geometric shape I'm associating with this algebraic equation. What does it mean? Yeah? Yes?
That every x coordinate that is squared corresponds to that y coordinate.
Not precise, but relatively good. Can someone makes it precise? Because it's a bidirectional statement. It's biconditional. So it means that if you pick any point randomly on this shape, it has two coordinates, alpha and beta, yes? This is clear because that is a point in the plane, so there are x and y coordinates associated with it. So this means that these coordinates satisfy this algebraic equation. So this means that if this point is on this curve, then this is guaranteed that if you square alpha, it becomes what? Beta. Yes? That's the meaning, but it's not finished. Another thing is that if you find a point, you don't know it is on this shape, but you know that this equation is satisfied. Then you can conclude, yes, this point is on this shape. Yes? So when I say that y equals to x squared is an equation representing this curve, it means two things. First thing is that if I pick any point on the shape, the coordinates of that point satisfy this equation, and vice versa. Any point whose coordinates satisfy this equation, if you go and look it, it is exactly on the curve. So this is extremely important, not for circles, not for lines, for any shape that you have, any connection between geometry and... So whenever I say that find an equation of this shape, I mean use the geometry of that shape to find a relation between the coordinates of the points that lie on that shape. Yes? That's the meaning. So now, with this introduction, if I ask you to find an equation for this circle, what do I mean? I mean use the geometry of the shape to find a connection, a relation between x and y coordinates of all the points that lie on the circle. That's the meaning when I say find an equation of a shape, yes? So then it means that, okay, let us draw the coordinate system. So the question is that I give you R is given, and I give you C. Because if I don't give you R, if I don't give you C, your circle is not specified. If I ask you to write an equation for this circle, I have to give you the center of the circle and I have to give you the radius of the circle. Otherwise, I cannot expect you to be able to draw that circle. So in analytic geometry, when I say give me the radius, it means that I give you a number, which is the length of the radius, and I ask you to give me the center. What does it mean? Because center is a point, it means that give me the coordinates of the center. So assume that alpha and beta are given. This is the center, and R is also given. And now I ask you to find an equation for this one. What is the meaning? I just told you. It means that take any point that you like on the circle, any point, let me call it M. Of course, you know that this point has two coordinates. One of them is called x, the other one is called y. I want to use the geometry of this to be able to relate x and y together. That's it. So what can I do? There is one important property of a circle. What is the important property of a circle? Geometrical property? Yes?
It has no edges.
No, I mean, these are, no, I mean very, very concrete. What is the definition of? Yes?
It has 360 degrees.
No, come on. The simple thing about circles. You need to write some science fictions. Yes, you will be good in that. So, because I couldn't imagine even these things you will tell me when I ask you what's the property of a circle. Yes.
It's the relation with pi, right?
Come on. What is a circle in the first place? Yes.
The radius is
No, the radius is what?
is the same everywhere.
So what does it mean?
It's round.
I think they have it. I think they have it.
Okay. Yes, Rob?
Do you mean that it's a bunch of points where the distance is
Exactly.
the same?
Is the distance to some point is fixed. So the property of a circle is that it doesn't matter where you are sitting on the circle, your distance to the center is the same. Yes, if you are here, your friend here, the distance from you and to the friend, so the distance, if, of course this is not a good metaphor, but assuming that the earth is actually a sphere, it doesn't matter where we are sitting on it. If we are in the sea level, our distance to the center of the earth would be the same, something like that. So that's also for the circle. So every point, it doesn't matter where are you looking at that. If you are on the circle, it is clear the distance from that representative point to the center of the circle, regardless of the location of the point, is equal to the radius of the circle. Actually, that's the definition of the circle. Yes? Yes? Okay, so one thing I know is that for every m on the circle, we have mc equals to r. Yes? This we know. Of course, to make things clear, I just have to show you somewhere, but it doesn't matter where m is. Okay, but now you need to remember some formula from Math 2C, and that is the distance formula, okay? Because what was my goal? Don't forget, I want to find a relation between x and y. Relation means equality. I need to set up an equality between x and y. So if you remember, do you remember the formula for distance between 2 points? Let me just recall you. In Math 2C, we had this. So if I give you a point A with coordinates x1 and y1, and if I give you another point B with coordinates x2 and y2, and then if I join them and I ask you, can you tell me what is the distance between these 2 points if I give you these 4 numbers? You remember? Anyone remembers? Of course, you really don't need to remember because you can immediately construct that, but do you remember d is equal to what?
No, I don't remember the formula, but I know you can calculate it by making a triangle.
Yes, Pythagoras theorem. So you can just do that.
Yeah.
Okay, so from here to here is x2 minus y2, y1.
Yeah.
And then from here to here is y2 minus y1. And then you are supposed to find this distance. So distance is this number squared, so it doesn't matter in which order I write it. x1 minus x2, of course, is not equal to x2 minus x1, but if you square it, it doesn't matter. And the same thing here. This becomes the hypotenuse squared. Yes? And then what I need d. So it becomes the square root of it. Well, what is this? Is the distance formula. So what is this? This means the distance from M to C is equal to number r. So what can I write for the distance? According to the formula, this is a big square root. I have to put the difference between the x coordinates here. The x coordinate of M is x. The x coordinate of C is alpha. The difference between them becomes x minus alpha and then to power 2 plus the difference between y coordinates is squared, so this means y minus beta squared is equal to r. Agreed? Okay, but usually putting this square root side is not that beautiful, so let us just raise it to power 2. Get rid of that one. So this is why people write an equation for the circle in that way. Yes. I really recommend you try to have this in your memory. So if I am supposed to ask you what is an equation of a line, I am supposed to give you 1 point on the line and the slope of the line. So how many pieces of information I need to provide for you so that you can give me the equation for the line? 3. Because 3 pieces of information, because when I say a point contains 2 pieces of information, x coordinate, y coordinate, and the k value. And how many pieces of information you need to be able to write an equation for a specified circle? Again, 3. The coordinates of the center and 1 number as the radius. As soon as you have those, As far as you have those, you can immediately put them in this, and then you find an equation. Do you see that we are done here? Because what I am supposed to find, I am supposed to find a relation between x and y. And I got it. Of course, this is not as simple as the equation of a line, but this is how it is. So it is quadratic, both in x and y. Equation of the line was of first degree, both in x and y. Yes? Okay, so this is one thing. So if I ask you example, of course we can discuss about these circles a lot. Actually, that's my intention, to talk about these things in math specialization. So circles, ellipses, and things like that later. But let us just keep it short for math for purpose here. So write down an equation of the circle of radius square root of 3, centered at C minus 3 and minus, let me write plus 2. That's extremely simple. I'm just writing this example so that we use the formula once to get used to it. Okay, let me change this. Okay, so what can I write? And by the way, this formula is in the formula sheet as well. Okay, but this is not hard to remember. Okay, so what should I do? So you see, I have this formula, and then I know that this r is 3. And what is playing the role of alpha? Alpha is minus 3, and what is beta? Beta is 2. So what you need to do, just put them here. This becomes x minus 3 to the power of 2 plus y minus 2 to power 2 is equal, oh sorry, this is not 3, square root of 3. Square root of 3 to power 2. And I myself prefer to simplify it a little bit, so this becomes x plus 3 squared, and then you have y minus 2 squared is equal to 3. So that is an equation as I was expecting you to write down for this circle. And for example, they might give you this and they might ask you to draw the graph of this one. So that is up to you to recognize that this is a circle, be able to read the coordinates of the center and the radius from the equation. Yes. For example, do you think that this is a circle or not? Is this a circle?
Yes.
If this is the circle, you need to tell me what are x and y coordinates of the center and what is r. R is
1.
R is 1 because this is coincidence. There is no guarantee that this number that you see here is r. A square of this number is r, because in the standard form, what is written on the right hand side is r squared. But here in this case, it doesn't matter. And what is c? What is the x coordinate of c?
0.
0. And what is the y coordinate?
-1.
Negative 1. Because here it appears with positive sign. Yes. The standard form, look here, it's negative, negative. So if you want to understand that, you have to compare the equation given. And for example, I can give you, in this course we will not give you, I just want to tell you, we were supposed to study Math 3C, which was limited. So I can give you this and I ask you to draw the graph of this one. So you immediately realize that you have to find, this is circle, and then when you understand the circle, you find the radius and the center, and then you can use the compass or whatever to draw that one. Okay? Okay, but one thing is important for our purpose in trigonometry is the unit circle. So the unit circle means the circle whose radius, first of all, is one length unit, and its center is the origin. That's called the unit circle. Okay, so the unit circle is what is the equation of the unit circle? Can you tell me without me telling you? Because the unit circle is also a circle, but it is centered at the origin and its radius is 1 length unit. No one else? Yes, Ricardo?
X squared plus y squared is equal to
1. So it's correct. So remember this. This is good to remember. This is a very famous equation. X squared plus y squared is equal to 1. It's the unit circle. It's an equation for the unit circle. By the way, why I say an equation, not the equation? I'm always saying an equation. Might be mistakenly I say the equation, but this is not possible to say the equation, because if I multiply everything by 2, that is another equation. From algebraic point of view, it is 2x squared plus 2y squared is equal to 2, but it will represent exactly the same shape. So I cannot say write the equation because there is no consensus on that. But this is the simplest form probably. Okay. So that's the unit circle. Okay, but let me also draw your attention to one important point, and then we can pass. So remember this. Okay, and then so what does it mean? In other words, if you want to say what is the meaning of the unit circle, it means that if you go pick any random point on the unit circle, the coordinates of that random point x and y satisfies this equation, and vice versa. If you pick a random point on plane and investigate that the coordinates satisfy this equation, then if you go and locate the point, you see, the point is on the unit circle. So that's exactly, just repeating things so that you can digest things better. Okay, so one thing, let me just go in passing. Let me change my color. Might be it's not that relevant right now, but it will be in the future. So if I just try to write this, because by the way, can you feel a difference between this way of writing and usually when we write, we don't have a mixture of x and y. If I have a function, I have y on the left hand side, and whatever I x have, everything is on the right hand side. The y is on the left, everything else is on the right. That is called explicit function. Yes, explicit. But you see that this is not the case here because x and y are not following that order. I have a mixture of x and y on the left, and I have a constant number on the right. Usually people call it implicit. Implicit, not usually, this is the name, but it is, I would write implicit function, and then I put this in the quotation mark because that's not exactly a function. I will talk a little bit about that. So let me just try to simplify that. Do you agree with my simplification here? So I move x squared to the right, so it becomes y squared is equal to 1 minus x squared, and then I will take a square root sign from both sides, and I write this. So do you agree with that? Yes or no?
Yes.
Yes or no?
Yes.
No.
No.
There is a flaw in it. What's the flaw? Yeah?
Both negative and positive.
Plus and minus. Extremely important. Because that's extremely important. By the way, if I ask you to draw the graph of this, you will draw the whole circle. But if I ask you to draw the graph of this, it will not be the whole circle. Why is that? It's clear. Because by this equation, y is the answer to a square root, so it is always non-negative. So when y is non-negative, you cannot go below the x-axis, because when you go below the x-axis, y is negative. So remember, if I ask you to draw the graph of this, you should draw the full circle. But if I ask you to draw this one, you should draw only this part. And if I ask you to draw this one, you have to draw only the lower part. So this is this branch, this is this branch. That's why it's not a function. A function should be clear. If I draw any vertical line, it should intersect a graph exactly, not more than 1 point. Okay? But you see that if I draw a vertical line here, it will intersect at 2. But if I split it into 2 branches, each branch individually is a function. But the concept as a whole is not a function. Okay, let us just put this aside. The only thing that I want to remember from this long introduction is the formula for every circle, and especially for our course, which is important, is this circle. Okay, now let us go back to trigonometry. So you already learned the definition of sine, cosine, and tangent in a right angle triangle, but you can momentarily forget about all those things that we learned. We just can start trigonometry in the unit circle, and then I can find the connection between this thing we learned and what we have already. So, but the point is that we have a better thing here. So do you remember, of course, I have already taught you this. So I draw a unit circle. So let me just draw this. So first of all, this is the unit circle, and in trigonometry, I assign a point on it, which is by convention this point on the horizontal line. By the way, when I say this is the unit circle, so immediately you can tell me the coordinates of these 4 points, yes? Because when I say this is the unit circle, I mean the center is at the origin, and I mean that the radius is equal to 1 length unit. So if I ask you what are the coordinates of these 4 points, which are actually important for our course, is you should be able to tell me what are the coordinates of this point? 1, x is 1, y is 0. 1, 0. What is this one? No, 0, 1. Because x is 0, y is 1. What is this one? Minus 1 and 0? 0 and minus 1. Okay? But this one is called the origin for the unit circle. A is the origin. And we also assign a direction that is convention in mathematics. Counterclockwise direction rotation is always assumed to be positive. And then clockwise direction is considered to be negative. Okay, and this line is also extremely important, this horizontal line. So that is the origin of the unit circle. I'm not saying the center is here, but the origin of the unit circle is here, and this line, horizontal line, is important. Now, I want to talk about a trigonometric angle, because when I say theta is a geometric angle, what do I mean? It means the minimum possible value is 0 degrees, and the maximum possible value is 360 degrees. That's a geometrical, actually, angle. But in trigonometry, we want to relax this condition, yes? We want to extend or modify, generalize. We want to consider angles greater than 360 degrees. We want to also consider negative angles, okay? So that's extremely possible in this setup. So, what do I mean by a trigonometric angle? So, angle has 2 arms, yes? Every angle. So if I ask you denote 30 degrees, what do I mean? I mean that you always, be careful, always you start from this line, horizontal line, and start rotating about the origin in appropriate direction with that amount, yes? So here 30 degrees is positive. So I start from here, I have to rotate about the origin in the positive direction. How much? 30 degrees. Then I will end up at the point, yes? For example, I will end up here. This is 30 degrees. Okay? For example, I can consider minus 60 degrees. For example, let me have another angle. For example, alpha minus 60 degrees. What do I mean by this? Again, don't forget, you start exactly from here, and then you rotate 60 degrees about the origin, but because this sign is negative, you have to go in the other direction. So you rotate and you will end up, for example, somewhere here. So this angle that you see is minus 60 degrees. One thing which is very, very important for our course and will matter eventually is the final point. Okay? Not the, of course, both of them are important. The size is important. But what matters most for us, understanding that the final point is crucial here in this case. Is that clear? Now I think it is clear that I can talk about any type of angles that I want. So I already talked about negative angles. I can talk about, for example, angle, so let me call it a beta, and then I can call 700, for example, 50. 765, okay, so let us see how it goes. And then I put this degree. What do I mean by an angle 765 degrees? Again, I start from here and I start rotating about the origin in the appropriate direction, positive. How much? 360 degrees. So it is clear, if I just go one full round, it is not finished yet, because when I go one full round, it is 360 degrees. I go another full round, it becomes 720 degrees, not finished yet. So I have to continue 45 degrees more. So you see, in principle, you come here, you go back here, and then you continue until 45 degrees. Or something like that. If from here to here is 45, yes? And then I end up somewhere. Okay? So remember that every point on the unit circle has a unique x and y coordinates, but doesn't have a unique name for it. Yes? For example, if I insist to give a name for this point, one name for this is 30 degrees. One name representing that final point. Another name, can you tell me another name which gives me the same final point? For example, 390 degrees. Yes, 390 degrees is a different name, but it will end up exactly at this point. Yes, because you go one full round, it is 360 degrees, you have to continue 30 degrees more and you reach exactly at this point. So in this way, based on your intuition, how many names I can assign to this single point? From angle point of view, infinitely many. But how many coordinates I can assign to this single point? How many x's and how many y's? One x and one y. So it's unique. The name is not unique from angle point of view, but the coordinates are unique. And this is good, because now because whenever something is unique, I can give it a name and then call it that thing, yes? So now I do this for you. So whatever I want you to learn, this which is extremely important, is this one. If you really learn that one, mainly you don't have any problems in this lesson for this chapter. So assume that I give you a trigonometric angle. What do I mean by a trigonometric angle? It means that it can also be negative, it can also be larger than 360 degrees. Whatever it is, it ends up at one single point. So assume that finally it ends up here. Okay? And then what you do, for example, this is your angle. What you do, you take the coordinates of x and y of that point, and then you say that sine of this angle is defined to be the y coordinate. That's it. So when I give you an angle, the first duty is to find the location for corresponding to that angle, wherever it is, and then everyone agreed that the coordinates are unique. Read the coordinates. The y coordinate is defined to be sine, and the x coordinate is defined to be cosine. And if I ask you what the tangent of that is, you would say y over x. Here, of course, obviously, x shouldn't be equal to 0. Otherwise, this fraction is not defined. So extremely very simple. It's a very simple idea, but you need to train your brain to get used to it. Is that clear? That's the way that we define sine, cosine, and tangent. Of course, you might say how is that possible? We are defining sine, cosine, and tangent in two different ways. To be honest, in mathematics, we cannot do that unless I can prove you these are consistent. Okay, they are not talking different things. We should be able to prove that this is consistent. We will talk about that later. But to practice this a little bit, do you remember we had some famous table in Math 3C? So let me just write it down here. So this is the table. You don't need to memorize that, but you need to remember the names here because those are famous angles. So what we had, so let me write sine theta, cosine theta, and tangent theta here. Okay, so the angles which are famous, I actually did it in that video. You can just listen to it again, but we did it in Math 3C as well. So these are famous ones, which is not relevant to our discussion now here, but for the information and completeness, I write them down. So sine of 30 degrees is 1/2. This is a square root of 3/2, and this is a square.
90 degrees?
Pardon?
What about
I will come back. So this is why I put empty places. And then here, this is 1 over square root of 2 in your book. Some books write it as the square root of 2/2. And then the same thing here. Yes. And then here you have 1. And this is the square root of 3/2. And then you have 1/2. And then you have square root of 3. Okay, today, using this, we can add something here. So I can say what is 0 degrees. We can talk about 90 degrees. We can talk about 180 degrees. And then we can talk about 270 degrees. And then we can also talk about 360 degrees. I limit myself to geometrical angles here because still they are most famous ones for us, yes? I couldn't do any one of them. If you go and look at that video that I've uploaded, and I of course did it in Math 3C as well for you. So here, I could do it in a right angle triangle, but none of them can be done in a right angle triangle. Because what was the restriction there? The angle should be an acute angle. Acute angle is strictly between 0 and 90 degrees. So none of them is strictly between 0 and 90 degrees. So 0 degrees, 90 degrees, 180 degrees, 270 and 360 degrees, we can immediately understand it from this picture. If you don't mind, let me start with 90 degrees first. So what is 90 degrees? Where is 90? So the first duty I told you, whenever you want to calculate sine, cosine, and tangent of a given trigonometric angle, first duty is to find the final location. So where is the final location for 90 degrees? You will start from here always, rotate 90 degrees, and end up here. And then your duty is to find the coordinates of this point, but you already did that. So what is that?
0.
X coordinate is 0, Y coordinate is 1. And according to the definition, Y coordinate is sine, X coordinate is cosine. So Y coordinate, read it, it's 1, X coordinate is 0. And then you need to divide this number by that number, which is not possible because X is 0, so it is undefined. So tangent of 90 degrees is not defined. Okay, now let us go to 180 degrees. Where is 180 degrees? You start from here, you rotate 100 degrees, and then you end up here, and then your duty is to read the coordinates. What are the coordinates? X is minus 1, 0. And then I ask you, what is sine of theta? It's the Y coordinate, which is 0. And then X coordinate? Minus 1. And then you divide this number by that number, which is again 0. Because 0 is in the numerator. So this is 0. Okay, one more. 270 degrees. Again, I start here, I go not 1 full run. I go 3/4 and I reach here. So what are the coordinates?
0.
X is 0, minus. So I go back there. So the Y coordinate, the X coordinate. So what is the tangent?
Undefined.
Undefined. Okay, I just wait for you to write this for me. What is 360 degrees? You go one full round, you reach to the origin of the circle. So, yes?
1, 0.
This one is 0, 1, and then 0. As far as you got this, you don't need to even think twice because this is exactly the same thing. Why is that? Why this is exactly the same as 360 degrees?
It's the same point.
It's the same point, even though it's a different name. But I told you that as far as sine, cosine, and tangents are involved, only what matters? Only the final point matters. Yes? That's why we have this. So this table will give you, of course, we will learn some tricks. So in Math 3C, this was the end of the story. But in Math 4, we learn some formulas. For example, you can calculate exact values for 15 degrees, 75 degrees, 135 degrees or so. Okay, so here, something that I want you to learn is how to exploit symmetry arguments here. Okay, so let me see that I follow the book. Or yes, I want to have, of course, all of this I did it in Math 3C as well. So I have to, okay. So they have just immediately gone to the, they have assumed everything in Math 3C to be known by students. I have jumped to actually more advanced things. So what I covered is not in the book right now because they have started from Math 4. But anyway, something that I want you to learn is how to exploit symmetries to answer some questions. For example, in this setup, I can ask you, what is the sine of 120 degrees? Okay, exactly. So the question that I might ask you is evaluate or justify the value of this exactly. Okay, so what I'm supposed to do if I want to answer this, you need to understand a little bit this graphical point of view. And then, of course, drawing things very precisely is hard. You need to try to have a good imagination. Of course, if you have GeoGebra available, you can draw a better picture. But the first thing that I do when I want to understand this, first of all, I realize this number is not that famous. Because the famous numbers I have in my head. And 120 is not one of them. And when they ask you to find the exact value, it means that the calculator is useless because calculator will give you approximate values. Okay? Of course, you have Casio, it will give you the exact value. But anyway, I don't know how to do it in Texas Instrument. Probably that's also possible. And by the way, we can also use GeoGebra to see if GeoGebra works or not. Anyway, if I want to do that, my first duty is to go and find 120 degrees. So I start from here, I rotate 120 degrees. Up to here is not finished yet, it's 90. I have to go how much more? 30. So it means that I go 30 degrees more. So this part is 30 degrees. And I end up here. So what I need to read are the question marks here. The only thing that you have for this kind of questions, in the national exam, of course, you don't have calculator with you for the part that you are not allowed to use the calculator. So, but this is given to you. The formula sheet is always given from the beginning to the end. So you need to relate. So if I ask you where is 120, be careful. 120 degrees is from here to here. And I want to read the coordinates here. How can I do that? You need to be able to connect this point somehow to one of those numbers, which you have the table at your disposal, and then try to use those information to read the coordinates here. So if I ask you to do that, with which one of those angles you connect this angle? It's a little bit ambiguous question. I am counting on your memory a little bit, yes?
60 degrees.
60 degrees. How? Because if this is 120 degrees, how much is left for me? here, 60 degrees. So this means that if I find the mirror image of this point, this is the mirror image of that point, and when I connect it here, can you tell me how much will this be then? 60 degrees by symmetry, yes? So if this is 60 degrees, it turns out that this is also 60 degrees. But now tell me, using the table, can you read the coordinates of this point? The answer is yes, because this is the final point corresponding to 60 degrees. Okay, so there are two coordinates. Can you read them from the table? What is the first one? The first one is cosine. Cosine of 60 degrees is?
1 over 2.
1 over 2. And what is the y coordinate? Square root of 3 over 2.
Yeah.
But that is not what I need. I need the coordinates of the red dot. But this is now easy. So can you tell me what are these coordinates?
Negative.
This is the mirror image. Does mirror imaging in this situation affect the y coordinates? No. I'm just double writing everything, but probably this is the one you need. Yeah. But if I ask you what the question mark here is, you can answer to be -1/2. Yes or no? Okay, now can you tell me eventually what is sine of 120? What is sine of 120? Yes?
Would it be square root of 3 over 2?
Yes, because sine, when I ask, so do you understand the method? So first of all, I found the final point of this, and I realized that, okay, this angle is not in my table, so what can I do? I try to use my imagination, actually, Matthias did, so, and then we just got this one, yes? Yes. And then when you read this one from the table, you have to go back here and read the information here. So what can I write here? Square root of 3 over 2. If I have asked you what is cosine of 120 degrees, what's your answer? -1 over 2. And I could also ask what is the tangent of 120 degrees. What's the answer? You can divide these two numbers, yes? You divide sine over cosine. What is the answer? It's minus square root of. Yes or no? Okay, so that is what we actually calculate. So you see that still, with some tricks, I can actually calculate the angles exactly, sine, cosine, tangent, which are not in this table. Okay, using these kinds of symmetry arguments. But if I ask you what is sine of 15 degrees, we will find a nice way, a little bit more complicated, to be able to answer that exactly. But it is not these kinds of reasonings. We need more formulas. These formulas that we find from here are not enough for that. Yes?
Yeah, so if we get this kind of question on an exam, how do we motivate it? Do we need to make a drawing of the units?
No, usually these exams appear in those parts that you need to write the final answer.
So just write the answer.
Yeah, but I mean, because it is, if you want to motivate, you need to more or less say write what I said.
Yeah.
Which is probably a little bit hard.
But
Yeah.
it's more likely that we just need to write the answers. Then it's up to us to do.
Yes, yeah, something like this. This is my experience from those. Okay. Any questions here? But for me, I have it in my memory. For example, can you tell me what is the name of this pair? 60 degrees and 120 degrees. There is a name for them. This is a pair. They add up to 180 degrees. There is a name for that. They are called supplementary angles. Okay? Yes. So if they add up to 90 degrees, they are complementary. If they add up to 180 degrees, it's supplementary. But by the way, let me ask you a little bit tricky question. Can you tell me what is the supplement of 20 degrees, 200 degrees? In geometry, this is nonsense. But in trigonometry, it's minus 20. So minus 20 plus 200 becomes 180. So if I ask you what is the supplement of 200, don't say that it doesn't exist. Yes, it exists it doesn't exist in geometry, but it exists in trigonometry. So the supplement of this one. For example, what is the complement of 105 degrees? Is minus 15 degrees. That's the complement of that. Okay? Okay, so this is what I expect you actually to know. Yes?
What's the reasoning if it's on the third quadrant, like tredje kvadranten?
Yes?
It's like 300 degrees. What's the reasoning? Do you like take the symmetry of that and then the symmetry of that?
No, you need to give me. You need to give. For example, if I want to answer a question like this.
Like sine 300 degrees, for example.
Okay, so the sine of 300 degrees we end up in the fourth quadrant.
Yeah, exactly.
Yes. So let us see what is that one. It doesn't matter, but
Like
because the angles we have. Usually, it's better to relate them to the first quadrant, because if you relate them to this one, then finally you have to relate this to that one. So it's not good. I mean it's not wrong, but why we should do that? Okay. So let me give you another example, as Hussein mentioned. So let me try to motivate. So by the way, let me write the remark here. So let me write the remark. Okay, so if alpha plus beta is 180 degrees, alpha and beta are trigonometric angles. Okay, what do I mean? I mean that they can be larger than 360 degrees, they can also even be negative. Anyway, if alpha plus beta is 100 degrees, they are supplementary. We learn something. We learn that sine alpha is exactly equal to sine beta. There's no difference between the sign of supplementary angles, but cosine of alpha is not exactly equal to cosine of beta. It is negative, and then because of that, tangent also becomes negative. That's also good to know. Otherwise, every time you have to visualize. That's up to you which one you prefer. Okay. So let me I don't think even we can start this new page, but this is what we have learned in Math 3C. So, no hurries, but it's important to know these things. Let me also answer Hussein's question. That's also a good exercise. So let us calculate everything, sine, cosine, and tangent for 300 degrees. By the way, I am not able to ask any arbitrary angle that I want. For example, I cannot ask you calculate sine of 29 degrees. By these methods, you don't know how to do that. Of course, when you punch it in the calculator, it will generate a number. There is a reason the calculator knows how to do it, but that's a little bit more advanced. It needs calculus and derivatives and things like that. But here, let us calculate sine, cosine, and tangent of this angle, which is doable. So what is your first duty? Is to go to draw a unit circle somehow, or a unit egg or whatever, and then try to find the final point of this. So what is that? If I go one full round, it becomes 360 degrees, but I have to stop before that. How much before that? 60 degrees. So this means that I start from here, and I go up to here, for example, 60 degrees before that. So okay, so this is 300 degrees. So this means that from size point of view, how much is this? Be careful. If I want to name it, I have to name it minus 60, but I'm actually writing only the measure, the size on it. Okay? So, and then this is the end point. So what is missing for me are these question marks. And I have to connect this point to one of those points that I have in front of me to be able to use the information to answer these question marks. So what can I do? Which, for example, always, I'm always prefer to connect it with some point in the first quadrant. By the way, I forgot to say, so this one is the first quadrant, so you go counterclockwise. This one is the second, the third, and the fourth. Okay? So always try to connect your point to some point in the first quadrant. So it means that you look up at the mirror image. Okay? And then when you found the mirror image in this way is not good because it ends up in the third quadrant. I want to end up in the first quadrant. So I do the mirror image like that and then connect it to this one. and try to understand this angle from size point of view. But by symmetry, you immediately realize what's the measure? 60. So this means that there is a deep connection between 300 and 60, even though they are not the same points, but they are connected. Okay, so what do? You go here and read the coordinates of 60. If I ask you, can you tell me the coordinates exactly? You say that, yes, the table is in front of me. The x coordinate is cosine, the y coordinate is sine. Using that, you can come back and read these question marks. So, mirror image, what happens for the x coordinate?
Nothing.
Nothing. Mirror image, what happens in this setup?
Negative.
Negative. And then if you want to answer this, you need to read the y coordinate, which is this one. And if this one is 1/2, and you just divide them, so this becomes this one. One thing that might be a little bit tricky, let me just ask you this one as well. Okay, for example, do you remember we had a remark? I told you that what is a relation that it is better to memorize between complementary angles? Sine of one angle is equal to cosine of its complement and vice versa. And we also learned that the tangents of complementary angles are reciprocal, yes? But let us try to understand it from this picture point of view. For example, my question is that if I give you alpha, a trigonometric angle, for example, and if I give you 90 degrees minus alpha, this is the complement of this angle, because if you add them up, it becomes 90 degrees. How they are connected? So you already know. If I ask you what is the sine of 90 degrees minus alpha in right angle triangle setup, in that setup, this is very limited. Alpha should be between 0 and 90. But now we can expand that. So you know what the answer is? Cosine alpha. And then what is the answer to this? Is what? Sine alpha. And then you know that tangent alpha multiplied by tangent 90 degrees minus alpha is just 1. Yes? But can you see why in this setup? For example, this is good to understand. You know, for example, assume that this is alpha. For example, where is 90 minus alpha? 90 minus alpha means that I have to rotate, but before reaching to 90, I have to stop. How much before that? Alpha degrees before. So this means that, I hope that you agree with me, if this part is alpha, then this is what? Which angle? Yes, do you agree? So you see, if I ask you where is the final point for alpha, you show me here. Where is the final point for 90 minus alpha? You show me here. Okay? Now my question for you is that, assume that the coordinates are x and y. Can you read the coordinates of this point if I give you these numbers? It's a little bit complicated than the case of these two cases that I solved. That was the mirror image. But you see, it's also a mirror image, but not with respect to the x-axis or y-axis. It's a mirror image with respect to this angle bisector. But forget about that. Can you tell me, if this is x, can you tell me what is this? Of course, the picture is really poor. It's actually distracting you. What you need to do in your head to construct this triangle in your head and this triangle in your head. So these two triangles, if you draw them precisely, hopefully you understand they are identical, congruent. Yes? It's clear because one angle alpha, and then the radii are the same. Okay? So what happens? This length is equal to this length. but this length is equal to this y, so this length is also y. And then this length is x, so this length is also x. But now, can you tell me what are the coordinates here? What is the x coordinate of this point? Everything is on the picture. What is the x coordinate?
Is it cosine?
No, what is the x coordinate on this picture?
Oh, it's y.
It's y.
Yeah.
And what is the y coordinate?
It's x.
X. So it means that the x and y coordinates are flipped. Okay, and that's the reason sine becomes cosine, cosine becomes sine. Yes? Is that clear or not?
Sure.
So if I ask you what is sine of 90 degrees minus alpha, you will tell me I find 90 degrees minus alpha and I read the y coordinate, which is x. If I ask you what is cosine alpha, you will tell me that I will find alpha and I will read the x coordinate, which is exactly x. Both of these numbers are equal to x, so they have to be equal. Okay? So that's also one way to understand that. Okay, I know that this is a very long lecture, but let me just finalize everything because I haven't even taught one single page from the book. Yes? It's everything you are supposed to know from Math 3C.
Everything.
Yes, everything except this circle one. Okay, so let me more or less I try to wrap it up. There are some information that we can immediately conclude from this setup. So what are these? First of all, let me draw this unit circle. It's good to know. So this is the first quadrant, second quadrant, third quadrant, and fourth quadrant. Yes? And then let me just do like that. So if theta is an angle in the first quadrant, second quadrant, third quadrant, and fourth quadrant. I don't want you to memorize that, but this becomes important. Sine, cosine, and tangent. I want you to know which. I want you to know the sign, positiveness or negativeness of these in different quadrants. In the first quadrant, all of them are positive. Why is that? Because sine is the y coordinate, cosine is the x coordinate. In the first quadrant, both of them are positive, so tangent automatically becomes positive as well. So now, can you imagine? So you should be able to imagine it. It's hard to memorize it, but every time you should visualize and be able to write, because we need that in some problems. Okay, in the second quadrant, what's your guess? Yes?
Positive, negative, negative.
Positive, negative, and then consequently negative. Tangent is simple because you just divide. Okay? So what is in the third quadrant? X and y coordinates are both negative. So then consequently tangent becomes positive. And then number 4, we have negative, positive. I don't want you to memorize that, but you should be quick in visualizing this and understand which one is which. Okay, another thing that I want you to describe here, if I want to give you a theta, any angle, negative, positive, even larger than 360 degrees, I want you to understand that this formula is still valid. Of course, we prove this in a right angle triangle using Pythagoras theorem, but we want to claim that this is still valid if the angles are negative, if the angles are even larger than 360 degrees. Why is that the case, do you think? The idea is very simple. We want to understand why this formula correct always, not only for acute angles. Why is that? You tell me theta is an angle. I will go in the unit circle and find the final location of that. Wherever it is, It's somewhere here. Okay? So assume, I don't know how to draw it, but for example, assume that you end up here. I don't know. Might be you have revolved several times and then you finally reached here. Okay, if I tell you, can you read the coordinates of this point for me? You would say yes. What are the coordinates? The x coordinate is what? Cosine theta. And the x coordinate is sine theta. This is on the one hand. On the other hand, we just learned before this, there is an equation for the unit circle. What is an equation for the unit circle? I told you that, remember. X squared plus y squared is equal to 1. On the one hand, this is the equation for the unit circle. On the other hand, the coordinates of this point is this. But I see that this point is on the unit circle. So it means that the coordinates of that point should satisfy the equation of the unit circle. So this means that instead of x, you put cosine theta and then raise it to power 2 and then plus sine theta to power 2 is equal to. So this now tells me that don't worry, this formula that we proved only for acute angles, now we learn that it is also valid for any trigonometric angles. Is that clear? So now from now on, don't worry at all, just use it, okay? Because I'm solving your concerns one after the other, yes? So this is solving it, yes.
No, but if it's in the second quadrant, wouldn't cosine be negative?
No, don't worry. Yes, cosine is negative, so it means this number is negative. But I don't care. I am just taking this number, whatever it is, and I am putting it here. Yes? That's actually the idea. Okay, so that is one thing that I want you to know, and then, okay, one thing that is also very important to know from this setup. Is it possible to have sine theta equals to 5? Can I have, by making theta bigger and bigger, do you think that I eventually reach to sine theta equals to 5 at some point? No, because sine and cosines are the coordinates of a point on the unit circle, but the maximum height is 1 and the minimum, I don't know, height again is -1, yes? And when I go to the right, the maximum value is again 1, the minimum value is -1. So that's extremely important to understand that sine theta in general can be at most 1. When I reach to this top, it becomes maximum. And minimally, it is -1 when I reach to this extreme point. And for the cosine, the same thing is true. Cosine is also between 1, -1, no matter how I choose this angle. 1 is when I reach to this extreme, -1 is when I reach to this extreme, yes? But for tangent, I do not have any limitations. And why is that? Because tangent theta is sine theta cosine theta, yes? Y over x, do you remember? Y is sine, x is cosine. I can, for example, what is happening, if I make this angle, the x coordinate is this much, the y coordinate is this much. When I divide them, I get a number. But when I start increasing this a little bit, what is happening? The x value becomes smaller, and of course the y value is also becoming bigger. So the denominator becomes smaller, and this one becomes bigger. So it means that I am increasing the value. But I can increase it unboundedly. Why? Because I can get closer and closer to 90 degrees. This x value will shrink and get closer and closer to 0. If this is extremely close to this point, then this is really, really small. Okay? And then, of course, y is not really small. It would remain around 1, but the denominator is extremely small, so this means tangent can blow up. So that's also good to write something like this. In general, there is no upper bound for tangent. There is no lower bound for tangent. Tangent can attain any value. So, for example, if I ask you what is theta so that this is true, you would say this is not possible. because the square root of 3 is more than. But if I write tangent of theta, find theta so that tangent of theta is 1000, you can find it. There are some angles whose tangent are 1000. So there is no bound for tangents, but there are some bounds for sine and cosine. Okay. So let me see if there is something that I have to review. Yeah, I think it's good to stop here. So that's actually a crash course on trigonometry, what we learned in actually Math 3C. Okay? But the next time, of course, we studied more in Math 3C. You remember what was the main topic we studied there? Yeah, the main topic there was trigonometric equations, which is also the topic here. But I actually more or less have nothing to add. I have to review everything because I did everything in Math 3C. We have to review. Of course, we solve harder problems this time. And then one part of trigonometry is completely missing here, and that was sine rule, cosine rule, and the area rule. I will not go through them. But in some of the proofs, I need them. So I just refresh your memory about the content without going deep into it. But I have seen exam questions in national exam that you have to use the cosine rule. Of course, the formulas are in the formula sheet, but might be you are absent-minded. So you have to refresh your memory about that. I will not be able to also cover that one because then we will not be able to even start Math 4. Okay? If you have forgotten, the good point is that you can go and watch the videos. That's it. Any questions?
No.
Yes?
Isn't another big point in this chapter trigonometric functions, or is that for another test?
No, actually, this chapter is very, very long, so probably I will not be able to finish it, even barely finish it for the Utvecklingssamtal.
Okay. So there will be 2 tests, or?
No, I will try to make it 1 test.
Okay, but it'll be very long.
Yes, yes.
Okay.
That's what I'm saying. Please catch up and study. Update yourself on video class. Thank you.
Thank you.